Hello everyone, and welcome back to our third Windows Dev Chat community call. We hear your feedback, and today's episode is special. We have a theme, and we can't wait to tell you more about it. I'm Gleb, a software engineer at Microsoft, and I'll be your host for today's call. Let's settle in with our favorite drinks and dive into the session. Today we'll look at the client platforms, also known as app development frameworks, from the new perspective and simplify the choice for you. Keep your topic-related questions in the live chat for Q&A section at the end of this call. We have an amazing lineup of speakers, experts in their fields, who will cover today's breakdown in details. To help you stay connected with our Windows Dev community beyond today's call, on this slide you'll find links to our video playlist, our social networks for the latest updates, and our blog for in-depth articles and tutorials. Mark your calendars for our upcoming events, and don't forget to fill out our feedback form and join after the call discussion in Discord community. Let's start with a top-level breakdown. Microsoft invests in a wide variety of client applications, frameworks, and technologies for developers to build for Windows and beyond. But this wide variety can overwhelm if you are new into Windows development. That's why we'll try to look at this from a different angle and streamline these options for you. Two questions representing two angles we aim for today. How you can break down these platforms from the perspective of programming language you prefer and capabilities you want to have. If you're trying to decide on a programming language, you'll have two main choices. Let's explore these options to see which one fits your needs better. If you go by capabilities, these platforms can be divided this way. In Windows-only approach, WinUI is the platform we recommend as the best choice for Windows. You'll have the deepest Windows native experience, squeeze out the best performance, the UI that aligns with Windows, as well as direct access to all latest Windows APIs and capabilities. Native cross-platform means you'll have the same native experiences, but you write once and run on multiple platforms. Technologies hide the device specifics into common abstractions, so you'll only need one set of dev skills and single code base to reach multiple platforms. .NET MAUI and React Native will showcase this option for you today. Web-oriented cross-platform shares the same benefits as native in terms of skill set and code base, but the focus is shifted towards the web browser and web application experience. This approach allows you wider availability and ease of updating, but involves web platform limitations. Blazor and Speedway will present this option for you today. Okay, we're done with the introduction, and let's start our speaker's content. Sergio, take it away.
Hey folks, I'm Sergio Pedri. I'm a senior software engineer here at Microsoft, and I work in the Microsoft Store client team, and I also lead the .NET Community Toolkit. Today, I'm very excited to talk to you about WinUI, which is our latest and greatest framework for building modern Windows applications. So let's start from talking about what is WinUI in a nutshell. So WinUI is the latest third-generation platform for building native UX apps for Windows, and it basically consolidates a lot of the previous UX technologies that used to be built into Windows, but it puts them into a single decoupled package that ships outside of the Windows SDK, which means that you're no longer tied to a specific Windows SDK that you're targeting in your app, and you can update this set of APIs that you use in your app independently from the Windows SDK you're targeting. And WinUI ships as part of Windows App SDK, which is this set of comprehensive tools, which includes both WinUI and a set of other APIs that you can use to develop rich applications. And all of these APIs are not just exclusive to WinUI, but they can also be used from other frameworks. So for instance, you can use many of the APIs in Windows App SDK from WPF or .NET MAUI or React Native as well. And .NET MAUI and React Native in particular also actually use WinUI 3 as their backend stack for rendering all of their UI. And here on the right, you can also see go back one sec, thank you. You can also see a high-level overview of where WinApp SDK falls into in the whole Windows tech stack, from apps at the top all the way to platform APIs at the very bottom. Now, what are some actual benefits of WinUI? So first of all, WinUI targets both down level on Windows 10 and also Windows 11 and allows it to leverage all the latest APIs that are available there, which means that your WinUI app will be able to reach over 1 billion devices. And there's lots of good reasons why you should want to use it. So first of all, WinUI powers a lot of key experiences in Windows. So like it's used by several inbox apps and several components of the shell and on Windows itself. So you'll be using the same exact UX stack that we use for all of our components. It also offers an optimized experience for modern hardware. So for instance, it includes things such as hardware acceleration, and it also has some new Windows Compiler runtime APIs to leverage DNPU on some of the latest Snapdragon devices. It also offers support for both C# and C++. You can pick whichever language you prefer between the two. And it fully leverages both x64, x86, and also the latest ARM64 processors. And lastly, it also offers a modern UI, and it's built with usability in mind, which means that it makes it very easy for you to support a whole range of accessibility features, such as the screen reader, for instance. And so let's dive more in detail about why you should actually choose WinUI for your next Windows app. So first of all, it offers the best expression of the fluent design pattern for Windows. And by that, we mean that all the controls and the styles that are included in WinUI come out of the box with support for the latest style guidelines for the fluent design pattern. And also, all of the controls in WinUI come out of the box with support for a wide range of inputs. So you can use all of them with touch, voice, mouse, keyboard, and all of that, which makes it's very easy to build apps which are accessible. It also offers a set of modern but familiar APIs. This is because they're, especially if you come from a background in other frameworks, maybe you've worked with XAML and C# before in WPF or .NET MAUI, you should feel right at home using the new set of APIs that are exposed by WinUp SDK. It also offers you full control and flexibility whenever you want to dive deeper into platform APIs for more advanced scenarios. And this is because it sits right above the platform APIs. So for instance, if you want to build some more advanced custom effects in your app, you can very easily do some interop with DirectX 11 or D2D and achieve some very cool effects that would not be really possible to do with other frameworks. And lastly, it's also where all the cutting edge innovation arrives first. And this is precisely because we're also using this framework to power a lot of key experiences in Windows. So this is where all the new controls and all the cool new APIs will be added to first. And so with that said, I am going to hand it over to Erin, who's going to walk you through a demo of how you can actually get started with WinUI today. Erin, take it away.
Yeah, hi everyone. I'm Erin, and I'm a software engineer here on the Windows Developer Experience Ecosystem and Partnerships team. And today I'm going to show you how you can get started building your own apps with WinUI using the community toolkit libraries, as well as the sample apps we have available in the Microsoft Store. So here you can see we have two great resources, the WinUI 3 gallery and the community toolkit sample apps, which can help you see what's available to build with WinUI and how you can get started using these respective libraries. So in this demo, I'm going to show you how you can replicate the settings experience that you've probably seen across the Windows OS and the community toolkit, and has some great components that I can use to quickly build out this UI. So here I have the sample app that I downloaded from the Microsoft Store, and this just shows examples of how to use all the common UI components that are available in the community toolkit library. So today I'm going to be specifically showing you how to build a settings page using the settings card and settings expander components. And here I'm just making sure that I have the settings control library installed. And I just did that through the NuGet package installer. And I want to make sure that I have the latest preview version so I can access the settings card and the settings expander components. So once I have that done, I'm just going to go back to my XAML to update the version in the .csproj file, and I can also go ahead and add the lines to import the library in the XAML. So if I go ahead and run my app, I should see that I just have a button in the center of the screen like this. And what I want to do is I'm going to go back to the Community Toolkit sample app, and I'm looking at the sample here, and I want to move my button inside of a settings card, kind of like this here, where it says yet another settings card. And I'm going to go into the source code, which I can access by clicking the blue button there and finding the content that it references. So here I have the source code, and I'm just going to copy and paste that into my stack panel that I have here, and I can just replace the button that's a placeholder with the button, or that was the button that was already in my app. So once I replace that, I'll have something like that. And when I run it, I should see I have a settings card here that looks a little bit different from the one in the sample app. So I'm just going to fix the alignment here to match that of the sample app. So I'm changing the orientation to vertical, the horizontal alignment to stretch, and the vertical alignment to top. And I'm also just going to add a little padding there to make it look nicer. So after the hot reload, we can see that now we have something that looks more like what we saw in the sample app. So going back to the Community Toolkit sample app, I want to add what is called a settings expander, which is essentially just a dropdown that can contain a group of cards. And if I click on the sample code, I can see how that's implemented. So we can see that we found an example of the settings expander. And you can also notice that there's a nested component here called the items component within the settings expander. And that is the component that's actually going to contain the list of cards that we want to include. So I just have to make sure that I include that when I define my settings expander. So here I'm just copying and pasting the definition for the settings expander and including that in my project. So I'm just going to add that to the top level underneath the stack panel, and I'm just going to paste it right there. And I'm also going to add the items component that I mentioned earlier. And so once I have that added, then I can just move my settings card inside of items. And so now you can see it sort of has this nested structure here. And that's what it looks like after it's cleaned up. So when I refresh my project, I can now see that the settings card is now inside of the settings expander. Let's wait for that to run. Yeah, so that's what it looks like. And now what I want to do is I want to add another settings card that showcases another useful WinUI component. So now we're going to go to the WinUI Gallery app, which I have downloaded here as well. And this can also be found on the Microsoft Store. So I'm going to be showcasing how to use the calendar date picker, which looks a little bit like this. And we can use the Gallery app to reference how to use it. So it'll just be this selector. And I can also look at the source code, which we see is pretty simple here. So I could just go ahead and copy and paste that. And going back to my project, what I want to do is just duplicate this settings card, and I'm going to replace the button that's on the inside with the calendar date picker. And I also went ahead and updated the Unicode value, or actually here, I'm just adding the text there to indicate that's a calendar picker. And I also updated the Unicode value for the header icon. And I can actually use the WinUI Gallery app to reference some helpful design documentation. So I can find other information about other topics like color and topography. And so for iconography, I just went down to find an icon that I liked, as well as the glyph Unicode value for that. So now if I go back to my project, I can see I have this really cool date picker and this new icon. And I can also just remove this header value to make it look nicer. But yeah, so that's just a couple of ways that we can use the toolkit as well as the sample apps to help build our WinUI apps. Thank you.
That was awesome, and hopefully that'll help a lot of people getting started. I really love how you can just use the gallery apps to quickly check out which controls are available and then try them out right there in the interactive XAML. All right, so before moving over to talking about other UI frameworks, as a recap here, here's 2 short links to actually go and download the apps. You can find both of them in the Microsoft Store. And with that said, before moving on to talking about other UI frameworks you can use, here's a little call to action. So first on the right, you can follow this hyperlink to land on the MS Learn docs page, where you can find a lot of useful documentation on how to get started. That includes guides on how to follow the best design practices for building Windows apps, how to get started with the various libraries, which APIs are available, and everything else you might need to actually build your own app. And also, if you want to join our community, you're very welcome to do so. First, we have a Windows developer channel on YouTube you can check out, where there's a lot of videos with sessions from Build and Ignite, and a lot of cool demos about WinUI as well. You can also join our WinUI community call. The next one is on January 22nd, where we're going to talk about what's coming up next in WinUI and WinApp SDK. And also, lastly, if you have Discord, you can also join our Windows App Community Discord server, where you can hang out with a lot of Microsoft engineers, Windows enthusiasts, and other indie developers, and also get help if you're building your own app. Yeah, with that said, that's all I have for you today. So thank you for joining.
Okay. Thank you, guys. And our next section is about web cross-platform. As we defined earlier in the introduction, I'll briefly remind you the main benefits. One code base across all platforms. Use your web skills to develop faster. Update all clients and platforms simultaneously, and be anywhere your user could be, web or app stores. And Justin will open this section with PWA platform. Over to you, Justin.
Yeah, thank you, Gleb. Hello, everybody. I am a senior software engineer here at Microsoft, and yeah, I will be covering progressive web apps. Okay, next slide. Thank you, Gleb. So what are progressive web apps, right? That's like probably the first question you're interested in. So PWAs are web apps. They're built with JavaScript, HTML, and CSS. However, they make use of some advanced APIs available in modern browsers to provide an app experience. They can run in the browser at a URL. So just as Gleb mentioned, meeting your users where they are, you can just give your user a URL and have them jump right into your experience. But they can also run completely independently of the browser and be installed from app stores like the Google Play Store and the Microsoft Store. You can even go to the Apple App Store using an open source project here at Microsoft called PWA Builder. So yeah, again, just a web app, but you making use of some new advanced APIs that modern browsers have to enable those kind of lower level app experiences. Okay, next slide, Gleb. Okay, cool. So next question I normally get, right, is like, what do PWAs look like? They're just browser tabs, right? This video, I think that's going to be playing here in a minute, hopefully, is going to show three different applications, three different PWAs running on Windows. So each app does something a little bit different, but the main point here is that these are applications running on Windows in their own window. You can do custom title bars and have custom controls up at the top. They work on mobile too, and you can see this looks, again, this is just an app on Android. I recorded it straight off of my Pixel device. This is the same code base running across all different platforms. So as it will show here in a second too, there's going to be, you can do like drawing, and this is doing on-device AI, no network connection needed. Again, all as its own app. This is another app. You can see, again, it's just an application, right? It's an implementation detail that it happens to be built with HTML, CSS, and JavaScript, but it's running on Windows as its own application. This is VSCode.dev, actually. You can see interacting with the file system using the native file explorer. I'll talk about this more a bit and capabilities here in a second. Full custom title bar up at the top. This is like VS Code running independently as a PWA installed from VSCode.dev, and is still full VS Code running on Windows. I think that's pretty cool, including all the file system access that they have, right-click menus, etc. Okay, next slide, Gleb. Cool. Okay, so capabilities. So there's a lot here. I'm not going to go through all of these. The point of this is, and as the video will show here in a second, these PWAs have access to a full wide range of capabilities. So you can start playing the video, Gleb, whenever you get a chance. But so for example, like file system access. So this is true, full-on file system access. This demo here is going to show local image search running on the GPU. So this is using MobileNet. It's going to run on the GPU on my AMD device, and will classify all of these images here in just, it did it maybe like 2-3 seconds. And then full local image search after that. Again, fully offline, no network connection needed. You can see it's using Fluent UI with the Fluent web components, and is its own application running independent of the browser. Okay, Cool. Yeah, so that touches on capabilities, and we can go to the next slide, Gleb. Cool. Okay, so myth busting. So we've covered a lot. There's, capabilities. There's a ton of capabilities we could go over. We covered what they look like. I think it's important, though, to maybe cover just like a few kind of myths out there, right, about PWAs. So I think the first one here is, I'm not going to cover, again, all of these, but I think there's two here that are kind of really important, right? So one is PWAs can't do much. Again, as we just saw with the capability slide, they have access to a full wide range of capabilities. All, not all of them, obviously, but a wide range of capabilities that your app may need. And then they can also run in the background. So you can do background syncing. They run completely, independent of the browser. They can run completely offline too. They don't need a network connection. And they can do things like push notifications, syncing data in the background, and more. Yeah, cool. Thank you, Gleb. So why choose to build a PWA? So I think there's kind of two main reasons here for me, right? So really the main reason is skill reuse. So Gleb had talked about like programming languages and stuff like that. And PWAs enable you to reuse your existing web developer skills to build apps that you can ship across platform. So these, they don't require any new skills. There's no plugins that you have to use. It's all just using standard JavaScript APIs that are worked on, in the open, in standards by multiple companies. There's no web view that you have to use. Again, no plugins. There's no new code editor. There's no reason to change how you build your application. There's no reason to change how you deploy your app. You can use all of those existing skills, tools, build pipelines, etc., to build applications. So for me, that is kind of one of the main reasons you want to go with a PWA is you or your team are a team of web developers, and you want to use those existing skills that you have. And yeah, you can see there's a few other kind of important ones here too, but for me, that's the big one. Okay, Gleb, thank you. Okay, so getting started. I know this is kind of quick, right? But we have kind of two things here. So one is getting, you can get started with the PWA Builder CLI, which a demo will show here in a minute. And then there's also a link there, the aka.ms link there will take you to the documentation. So that's going to take you to our PWA documentation, the intro to that. Through that, you can find all of our tools. You can find how dev tools work, including some of the specific progressive web app dev tools. You will end up on PWA Builder, which I mentioned earlier, and you will be able to find like our Discord and other things through there. Okay, Gleb, we can show the last demo. Okay, so this is going to be showing how that CLI works. So basically, if you've ever heard of the Angular CLI or the React CLI, or you're just like familiar with like Visual Studio templates, this CLI, which you can install with npm, as you saw me just do there, is going to give you a full template with all the code you need to get started building a PWA. It's going to include Fluent Design out of the box, all the other things you need to have it working offline, etc., and have it ready to go to the app stores. And again, all from just one CLI command that you run, and then you have an app that's ready to go, including even with like hot reload in the browser as you make changes. And then, yeah, dev tools you get in the browser too. And yeah, that gives you everything you need to get started building a progressive web app. Okay, cool. Thank you, Gleb.
Thank you, Justin. And now let's learn about Blazor from Daniel. Your turn, Dan.
Great, thank you, Gleb, and thank you, Justin. It's I gotta say, it's pretty impressive what's possible these days with the modern web platform and progressive web apps. That was pretty cool. So I'm Daniel Roth. I'm a principal product manager on the .NET team for ASP.NET Core. And one great way to build your next modern web app is using .NET and Blazor. What is Blazor? Well, Blazor is a modern front-end web framework based on HTML, CSS, and C# that helps you build web apps fast. With Blazor, you can build web apps using reusable interactive components that can be run from both the client and also the server so that you can deliver great web experiences. So what does it mean that Blazor is a full stack web UI framework? Well, modern web apps today take advantage of both the server and the client to deliver the best user experience possible. From the server, you can handle requests, you can access your server resources like your database and backend services, and you can dynamically generate UI content. From the client, though, you can handle user interactions. You can access client resources like their CPU, their storage, their memory, and seamlessly update the UI. With Blazor, you have the flexibility to use the strengths of both the server and the client to render your components and then optimize the user experience. And so the idea is that by building full stack with one language, one framework, one build system, all based on .NET, a cohesive development platform, you can build modern web apps faster. Now, Blazor is our web UI offering, and it comes loaded with lots of great features. It comes with a powerful reusable component model, so you can take pieces of UI and have them be reusable across your application and across multiple applications. You can easily handle UI events from your Blazor components, like button clicks and on-change events and so on. You can handle two-way data bindings between your app state and the state of your UI elements. We provide built-in components to help you build things faster, like components for forms and validation, also data grids. You can display large data sets in Blazor with full virtualization. You can build installable web apps, PWAs, with Blazor and support offline scenarios. And we provide rich tooling for Blazor, including hot reload support in both Visual Studio and Visual Studio Code. And while you typically write your Blazor apps in C#, Blazor also does support interop with JavaScript. So if you want to call into existing JavaScript libraries or browser platform APIs, you can do that too, and also call back from JavaScript into C#. Now, getting started with Blazor is really easy. You just go to blazor.net, and you can learn all about Blazor and how to set up your machine to first build your first Blazor app. And I thought I would show you really quick what that looks like. So if we could go to my desktop. Yeah, perfect. All right, so here I have, I'm on Windows and I have Visual Studio installed. You can also use Visual Studio Code. That would work as well. I'm just going to create a new project, and I'm going to select that I want to create a new Blazor web app. That's the template I'm going to use. And we'll go ahead and click next. And sure, Blazor App 1 sounds like a great name. I'm going to use .NET 9, which is our latest release of .NET that we just shipped, in a few weeks ago in November. And I'll just leave all the rest of the defaults and let Visual Studio then set up my my project for me for my first Blazor application. Okay, there we go. Let's take a look and see what we've got. Go ahead and pin Solution Explorer here. I'm just going to run this so that we can see what the app does. The default Blazor template will give us, some basic sample content and show us some of the foundational Blazor features, so we can see how those work and what they how they operate. My browser popped up over here on my other screen. There we go. Okay, so here's our Blazor web app that we just created. We have a couple of pages. We've got a home page, which just has some basic static content. We also have this counter page, which has the button that we can click and the count goes up. So we have user interactivity here. We're able to seamlessly update the UI. In the past, this would have required writing JavaScript code, but this is all done with .NET and C#. On the weather page, we have this table of randomly generated weather forecast data that's being streamed in from the server as the data becomes available. Okay, let's take a look at what the code looks like for this Blazor web app. Let me give myself a little more space. So that home page, that first page we looked at, here's the code for the home page. Now up here at the top, we have this @page / it's called a razor directive. This is basically saying that this component should render when you browse to / to the root of the app. That's how you set up routes for your components in Blazor. Then we have a custom tag here. This is a Blazor component that's built into the framework that's setting the page title on the page, like the HTML page title on the page. So Blazor, again, based on reusable components. We then just have plain old HTML. Blazor is based on HTML and CSS open web standards. So that's pretty simple. That's just the home page. What about counter? So in this counter page, again, we've got the app page directive setting up the route for /counter. Then we've got this interesting thing here. We have this render mode that's saying that this component needs to be interactive. It needs to be able to handle UI events like button clicks and on-change events and so forth. We're then setting the page title again. More just plain old HTML. Let's give ourselves a little bit more space so we can see all that code. There's a couple of interesting things happening here. Like right here, we are rendering the value. This @ says, please render the value of this current count field. And this current count field is coming from down below in our code block. And this is all just plain C#. You can think of Blazor components as just like a C# class. And this little code block at the end is just members in code that we want added into that class. So that's how we're rendering the value of the current count, which is just a C# field. And then down below, we've got an HTML button, normally HTML button, but it's got an on-click handler at on-click. Normally, you would say on-click and then put some JavaScript code here. But here we have a reference to a C# method. So every time you click the button, it's calling our increment count method, which changes the value of the field. The component then automatically re-renders, and we see the count increment. So that's how this is working. That's how we're getting that count to go up. To show you that's really the case, let's change the value here to say, instead of incrementing by 1, let's increment by 10. I'm just going to hot reload that into the running application and go ahead and start clicking. And now you can see the count goes up by 10. So that's pretty cool. Now, because this is also a component, each of these Razor files is a component. We can reuse it. Like if we go back to the home page and click on home, I can add a counter tag, just like that page title tag we saw before. And I'll save that to hot reload that into the application. And now you can see we've got a counter on the home page. We have a counter on the home page and then a counter at //counter. With reusable components, you can also like pass in parameters, like pass in data to your components. Like if we go back to our counter and let's add a property here. Let's call it, let's say, private. Was it public? Okay, public int increment count, increment amount is what I want. Like how much do we increment by? And let's call this a parameter. I'll just attribute it to say, hey, this is a component parameter. It's not just a normal property. And let's make the default 1. Okay, and instead of incrementing by 10, let's increment by increment amount. Let's save that into the running apps. Okay, so now on the home page, it should go back to incrementing by 1, and yep, it does. And then if we go to the counter that's on the home page, I should now be able to set that parameter using an attribute. So let's say increment count amount equals 10 instead of just 1. So now if we go, the one on the home page should still increment by 1. Yeah, oh, sorry, the one on the counter page should still increment by 1, but the one on the home page now should increment by 10. So that's how you can pass data into your components. Lastly, on that weather page, like how is that working? If we go look at weather.razor, you can see again, it's got a route. This page is using streaming. That means that it will stream in HTML content onto the page as it becomes available. Like if you have some long-running async tasks that are getting data that you then use to render some additional content, you can stream that onto the page. Below, you can see we've got HTML, and then we have an if block. You know, normal C# if block. We're saying if we have our weather forecasts, or if we don't have them yet, then just display this loading ... Let's see if we can see that like there. So like if I pause it, you can see there's that placeholder. And we'll let it continue, and then it streams in the rest of the data. If we do have the weather forecast, then we render our table, and we're just using a normal C# for each loop to loop over each forecast in our forecasts array to render each row in that table. Where are those weather forecasts coming from? Well, if we look below, we have this uninitialized async method that's setting up the data for the component. And right now, it's just simulating like an API call or a database query, some sort of async work in order to actually get the weather forecast data. That's what's causing that little pause before we see the weather forecast. Normally, you'd have like an HTTP client call here, and then we're just like generating all the weather forecast data, dummy data in memory and rendering it onto the page. So that's how that works. Okay, so that's your very basic introduction to Blazor. If you want to learn more, like I said, go to blazor.net, and then you can just click on the Get Started button and find videos and tutorials that will help you build your next Blazor application.
Thank you, Daniel. Okay, our next section is about native cross-platform as we defined in the introduction. I will briefly remind you the main benefits. Similar things about code base, skill set, and fast development as we mentioned for web, but the main difference is access to native UI controls, device-specific features, and API. And Beth will open this section with .NET MAUI.
Hey everybody, my name is Beth Massey. I am a product manager on the .NET MAUI team, and I'm super excited to talk to you about .NET MAUI. Here are some examples of cross-platform applications that you can build with .NET MAUI. So next slide. So what is .NET MAUI? .NET MAUI stands for .NET Multi-Platform App UI. So it's a mouthful, but we affectionately call it just MAUI. MAUI provides all the bindings and core components that you need to target Windows, Mac OS, iOS, and Android. It includes a device abstraction layer, which provides you a set of native controls and APIs. You can access over 60 device APIs like storage, networking, device-specific sensors, and capabilities, all with the same code. And if you need, you can still access all the platform-specific APIs directly. Because it's built on .NET, you do have full access to the .NET base class libraries, unified build system, and all the productivity tooling that you would expect from Visual Studio and VS Code. So the MAUI controls, the APIs, and the core components, they're all open source on GitHub. And there is a healthy ecosystem of third-party controls and components, just like you would expect from .NET. And in fact, in the demo today, I'm going to show you some of those great open source components. Okay, next slide. Here's an example of Fidelity, where they took and rebuilt their next generation of their Active Trader Pro platform. This is a kind of a day trader. Customers use this to day trade. It was originally a WPF app, and they've been on a couple-year journey with us and the MAUI team building a Windows and Mac desktop app with .NET MAUI. They're at .NET Conf that was last month. They had a session that went into all of the details and kind of a deep dive on how they architect this pretty fantastic solution. It's pretty deep. So we're very happy to see them launch. So to get started with .NET MAUI, you install Visual Studio, you can install VS Code, you can install .NET, and then MAUI it's just included in a workload. So once you install the workload, you can go to the CLI, the .NET CLI, and just type .NET New MAUI. Or you can use Visual Studio VS Code. So I'm going to show you real quick getting started. Flip over to my screen over here in Visual Studio. So you'll see I'm just creating a new project. I've selected MAUI. There are a few templates we're going to go through. First one is just the .NET MAUI app. So let's just create a MAUI app. I'm just going to name it whatever. I'll use a .NET 9, and I'll include sample content because in .NET 9, we have a new project template that includes some of the more popular open source, free and open source community components, like the community toolkit, as well as the Syncfusion toolkit for .NET MAUI. Syncfusion has been releasing open source controls. I think they started with a set of like 15 controls, and they just open sourced, I think, a couple weeks ago, a couple more. So they're kind of helping us and collaborating with us in building, fixing a lot of bugs and improving the quality, as well as providing a lot of controls. So I'm just in Visual Studio here. You'll notice that this is MAUI, so it's multi-platform. We have Windows, Android, iOS, or Mac Catalyst targets. I can deploy to Android emulators. Visual Studio makes all this tooling really nice. I actually have a device plugged into my machine right now. I'm also got connected to my Mac over here, so I could actually run right here from my Windows machine the simulators for iPad and iOS and that sort of thing. So you'll notice that the sample code that you get, it has models, it actually has data, so it uses SQLite database. So this is a full-blown application that manages tasks. It's like a task to-do list. So if you look at the builder here, you'll see that it's using the community toolkit, Syncfusion toolkit, and it also has like all the services that we need to work with data and our page models and MVVM. And so all the best practices of working with XAML and MVVM is also in here as well. All right, I'm just gonna start up the Windows machine so you can take a look and see what it looks like. I actually already have it deployed to my Android. And so if we want to, while that's building, we could take a look at what it looks like here on Android. So you'll see that I've got, a nice dashboard here. I've got the Syncfusion control, I've this chart control. Here's the Windows machine coming up. You'll notice that in the mobile app here, we can select items, we can clean them up. This is all using a SQLite database as well. Here's the Windows version. I'm in dark mode on my machine here, believe it or not. So we can change it to light mode here. It looks exactly the same. So same look and feel. So this is MAUI running on multiple devices. And so this is using the native controls of each of the platforms. So if you want to build native UI, You use XAML to do that, and this sample helps you kind of get started really quickly. All right, if we want to flip back to the slides, I have another piece of MAUI that I want to talk about. So MAUI is not just about native UI, it's also about hybrid and using web UI. So what are hybrid apps in general? So hybrid apps are really a blend of web technology and native technology. So you write your UI using web technologies that you may be familiar with. A lot of web developers out there in the world. You use HTML, CSS, JavaScript, and that's wrapped inside of a native app container. You have full access to the native platform features and device hardware here. And that can be mobile or desktop devices. So you can basically create the same web UI and reuse that across multiple devices. So this basically saves time. It saves cost, so that you don't have to rewrite or write specific native UIs for each platform. MAUI helps you do that in general because you're just writing once and deploying to multiple devices. But using web UI allows you to target the web additionally as well. Okay, so next slide. So in MAUI, we have a couple controls that allow you to do this. So, if you take a look, before I was showing just the MAUI layer, we have a couple controls that allow us to also run our web apps natively on these devices. So these are hybrid client apps. So this combines the web UI and the MAUI components together into a single native client app. So it gives you full access to those native platform capabilities, and it makes it easier to share that UI across the web hosting models and these native apps. So hybrid apps, they rely on MAUI for this native application container and native controls if you want to use them. So you could even mix the web UI with the native UI if you wanted. Now, no internet is actually required for this. Okay, the UI itself is packaged with the app. So MAUI hybrid apps have the full access to the MAUI abstraction layer here and the native device capabilities. So this makes it really easy to do native things that may be difficult or impossible to do on the web alone. Then it also gives you the ability to take your apps and, of course, package them for store distribution, whether that's Microsoft or Apple or Google app stores. Now, these two controls, they derive from the native platform's web view. So on Windows, that'd be Web View 2. These controls are called Blazor Web View and Hybrid Web View. Now with Blazor hybrid apps, you host the Blazor components and the Blazor Web View control. And you can use all the built-in Blazor, awesome Blazorisms like input controls, validation forms, all the stuff that Dan was showing you, that's right out of the box with Blazor. So in fact, we actually provide a solution template for quickly setting up a MAUI Blazor hybrid app and a Blazor web app that shares all of its UI. And I'll show that to you in just a minute. But starting with .NET 9, we also provide a hybrid web view control, and that allows you to use other JavaScript UIs in MAUI too, like Angular, React, Vue, or any other HTML or JavaScript-based UI, and package that with your MAUI app as well. This control provides, the basic interop between C# and JavaScript. So you can keep your business logic and native device access in C#, but you can leverage your UI that you may already have existing JavaScript assets that you probably have. So that's just another approach that you can take with MAUI. And remember, you can kind of mix these models together, which is kind of cool. All right, so let's go back to, I think, demo. Yeah, so all right, let me go ahead and shut that down. So let's just go ahead and create a new project. You'll see that we've got this new, we also have just a plain old Blazor hybrid app. This doesn't create the web piece. If you just want to create a single app, this sets you up for a hybrid. But I'm going to show you the new template here that also creates the web backend too. So let's just name it whatever. And I'm going to include the sample pages. Now, these sample pages are going to look exactly like the sample pages that Dan showed you. So you'll notice that we've got the MAUI app here. We also have this shared library, and then here's the web app. The shared is where all of the actual UI is. So we're sharing the same exact UI on the web and on the MAUI app itself. The way that we're rendering this is all through one Blazor web view, and here's just the web view control, and that's the only XAML that's actually in the MAUI app itself. Now, like I said, you can mix and match more things, but just by default, all the UI is here. All right, what I'm gonna do is, instead of just starting up the windows, I'm gonna configure the startup projects to be multiple startup projects so that we can actually see the web app too. Okay, so okay, let's get that going. All right, so here I'm going to just open up the homepage real quick because we're going to kind of walk through this. It's going to look very similar to the app that Dan showed. It's just going to have a little bit extra here just to kind of show you how you architect this application. So you notice here's the windows, and let me see the web guy went over on my other monitor here, and here's the web. Okay, so you'll notice it's exactly the same. You'll see like here's the counter page, here's the weather page that Dan was walking you through. There's the home page. Same thing here. All MAUI apps are always interactive. So there we go. We've got the interactivity. You'll notice though that there's this little blurb on this home screen that says, you're running on the desktop and using WinUI, and in this case, you're running on the web using Microsoft NT because that's my Windows machine. So how are we doing this? Now we want to use the same exact UI, but because we have different hosting models, we may have different implementations for what we need to actually do on the forms. So if I go back, take a look at, I've got this thing called iFormFactor. I'm injecting this service that has this same interface. So you define these interfaces that you use on your UI and your screens, and that actually is inside of the shared Blazor class library. Okay, that's where we've defined. And then in the apps themselves, in the client apps themselves, we have the implementations. So in this case, we're using the device info. So the idiom here. So it looks like my Android's not building here, but this basically just will put out the desktop or phone or whatever. And in this case, the platform to string here is just the platform and then the version of the platform. So this is how we're using the device abstraction layer. And if we go over to the web, I'm just doing a completely different thing. I'm just saying web, and I'm just using environment OS to string in that case. All right, so that's just the template, how to get started really fast. If you're doing it on the CLI, it's there it is. It's .NET New MAUI Blazor Web. Okay, so that's how you get started. And do I have one more thing? I think I wanted to talk about why you would choose one over the other. Okay, so Web UI, native UI, it's really about look and feel. Web UI typically looks the same across devices. It's controlled by CSS. So while native UI provides device-specific look and feel, especially with MAUI. MAUI is using like the native controls. So native UI can provide more seamless user experiences. If you're doing like high-performance games or that sort of thing, you may want to use native. Skill set: if you're more of a web developer and you already have a lot of JavaScript assets out there, you might want to think about reusing the Get UI like I just showed you. And typically, if you're a XAML developer, you probably want to stick with native. But yeah, I think the biggest benefit we're seeing, especially with a lot of customers that do go hybrid, is really about code reuse. They really want to target the web too, and they want to do it with a small team and a minimal amount of resources. And so this is a good option for them. So to get started with MAUI, it's similar to Blazor. It's all on the same website. It's the .NET website. It's .NET whack MAUI. This is the gateway to all of our community calls, and James Montemagno has a ton of resources and just literally get you started. If you click the Get Started button on that, it will walk you through how to set up your environment and how you can build your first MAUI app. So thanks.
Thank you, Beth. And finally, Kira will walk us through React Native.
Awesome. Thanks, Gleb. Hi, everyone. I'm Kira. I'm a developer on the React Native for Desktop platform team. And today I'm going to be talking a little bit about our next cross-platform framework, React Native. So for those of you who aren't familiar with React Native, let's go ahead and contextualize. React Native was a platform originally created by Meta with the goal for developers to be able to write app source in JavaScript to build native cross-platform applications for iOS and Android. JavaScript developers make up one of the largest segments of developers in the world today, and React Native enables that pool of developers to be able to build native applications without having to learn new native development skills or without having to hire specific engineering talent for each platform their app needs to target. Now, at Microsoft, within the client platform team, our goal is to enable developers to build Windows apps, and this includes JavaScript developers as well. And this is why Microsoft invested in expanding the React Native platform to additionally support building desktop apps for Windows and for macOS. So if we head to the next slide here, perfect. With React Native for Desktop, JavaScript developers can build native Windows applications in JavaScript without having to ramp up on C++ or C# Windows development. So let's first talk a little bit about why a developer would choose React Native. I just mentioned that React Native lets you build native apps with JavaScript and React, which is great for developers with JavaScript expertise. But what are some other reasons why React Native might be the right framework for your application? So just like MAUI, React Native lets you build cross-platform applications that target both mobile and desktop. Earlier, we heard Beth talk all about the benefits of cross-platform development, and those benefits also apply to React Native. With this platform, developers can maintain one JavaScript code base to build apps for iOS, Android, macOS, and Windows. Next up, React Native has a rich ecosystem and vibrant community. We have many community modules with support for cross-platform native controls and APIs. These modules are maintained in open source by developers in the community. And for the full list of supported modules, you can visit reactnative.directory online. React Native can also be integrated into existing native applications. For example, large production applications like Office have incrementally added React Native to their applications, allowing them to gradually modernize from their original internal framework. Next up, React Native gives you full access to native features. You can call native APIs from your app's native code directly, or you can use a native module. If there is a native API that doesn't have an existing community module, you are also absolutely able to write your own. And then finally, React Native lets you reuse existing React web code. Your non-UI web code can be directly reused, and your UI web code will just require some simple control translation. Okay, so let's talk a little bit about some other React Native capabilities. React Native apps are Win32 applications, and our core component suite is built using WinApp SDK's Scene Graph APIs. We have out-of-the-box support for WinApp SDK, and we also support hosting WinUI controls as well. React Native's APIs and core components are open source on GitHub if you want to take a look at the source for any of those. React Native also has a great developer experience. This is achieved through features like hot reload, debugging tools, VS Code, in VS Code, and more. So React Native currently is being used within several Microsoft experiences. And if we head to the next slide, we can take a look at the icons of some of those. Most recently, Office shipped their new in-document Copilot experience, which is built with React Native. If you're curious about learning more about how Office has leveraged React Native to modernize their product suite, we just gave a talk on this at Ignite a few weeks ago, and the recording has been posted online on the Ignite website under breakout session 304, if you want to take a look. All right, so let's take a look at some demos next up. And we'll wait for this to load. I think that's the demo for WinUI. Perfect, yep. All right, so first off, we'll take a look at the steps for instantiating a new React Native app. We'll start by opening our command prompt and running npx-yes at React Native community /CLI at latest. I'll go ahead and give my app a name. I'll choose sample fabric, and I'll specify the React Native version to be latest as well. So once I hit enter, this script will run, and this step is going to instantiate a React Native app for iOS and Android. And if I wanted to add support for desktop, I'll just need to run a couple of extra steps, which I'll do in just a moment. So my template app has now been created, and the next thing I'm going to do is add the React Native Windows package to my app using Yarn. And this will just take a few seconds to run here. Perfect. And then finally, I'm going to run yarn React Native init Windows -template cpp app -overwrite. And this will add Windows as a target to my React Native application. Once this step is complete, I'll now have a React Native application that can target iOS, Android, and Windows. And if I wanted to add macOS support, I would run a similar CLI step to my previous one to add macOS as a target as well. All right, so now I'm ready to build my React Native application. To do so, I'm going to run npx React Native run Windows, which I've just run here from my command line. And in just a few moments, my app is going to build and deploy. Perfect. So here is my new React Native application. As we can see, these startup steps were super simple to follow and only took a few minutes. And from here, I'm ready to begin developing my app. Now, we just took a look at the sort of template application for React Native, but let's take a look at a little bit more of a built-out React Native for Windows app. Here's the React Native gallery, and if you've used the WinUI gallery before, React Native gallery is the equivalent sample app for the React Native platform. It has lots of great links to get started with React Native development, as well as samples of supported React Native controls. For example, here is the page for the text component example, which is one of the core components in React Native. This control is built using WinApp SDK's Scene Graph APIs, and if I want to see the code used to render each component example, that's also included on the page. So earlier I mentioned that React Native supports hosting WinUI controls. We currently support hosting the full suite of WinUI 2 controls and are in the process of supporting WinUI 3 controls as well. Now, if I navigate to the calendar view page here, I can show an example of our progress. Here is the WinUI 3 calendar view running in React Native. The control is the same look and feel, whether it is running in a regular WinUI app or a React Native app. I've added some additional functionality to this sample by adding a header above my calendar view that displays whatever date is currently selected in the calendar. And when I select a date, I can see that date load in the header. So this functionality is super important because it shows that as the state of my WinUI control changes, my native code will send that event data back to my app's JavaScript so it can be used within my application. It's a great example of how the Windows client platforms are built to work together. So we know that React Native supports building cross-platform applications. And as the last piece of our demo here, let's take a look at React Native Gallery running cross-platform on macOS. Here's React Native Gallery running on macOS. The JavaScript source here is actually shared across the two platforms, and React Native handles pulling in the right native control depending on which platform the app is targeting. Because React Native uses native controls and theming, the app feels visually consistent with the operating system that it's running on. React Native allows developers to maintain one JavaScript code base to build native cross-platform applications. And with that, we can go and head back to our slides. And that about wraps up our React Native session. If you'd like to learn more about React Native, you can visit our website, which can be found at aka.ms/React Native. Our website has all of the documentation you'll need to get started with React Native development, and it also has links to past conference talks and blog posts that have been authored by our team. And with that, I'll hand it back off to Gleb.
Thank you, Kira. Okay, that was awesome. I think today we showed the programming language and capabilities breakdown, as well as get started guide for all platforms we recommend for new Windows application. Whatever approach you choose, there are always a tool to create engaging applications. Remember, the ideal framework is one that suits your specific needs and objectives. All right, now we move into our Q&A segment. We're excited to hear your questions, so please go ahead and type them into the chat if not yet. While we are collecting your queries, I'd like to remind everyone about the feedback form we have available. Your insights and suggestions are incredibly valuable for us, and they help us make these sessions even more beneficial for you. We also have an ongoing discussion on community-driven Windows App Discord server. You can join it after this call and continue your engagement, discuss today's topics, and connect with fellow developers. Okay, I'll check our comments. Is everything was answered in the chat, or we want to bring something on screen? Okay, my colleagues told me all questions was answered. We'll wait, I guess, a couple of minutes if you want to ask something about React Native, maybe. I'll remind you to revisit today's session or catch up on past discussions. Check out our playlist, which covers this and previous episodes. Stay tuned for our next call scheduled in, I think, early February. And follow us on social networks to receive latest updates. And that's all time we have. Thank you for all your thoughtful questions and contributions today. If there are any unanswered questions, we encourage you to join the conversation on Discord, and we'll do our best to address them there. Have a fantastic day and happy coding.